Now, I think I explained the basic functions of RecurDyn you need to know. To understand how to use them better, I recommend you to try them by yourself. You can use RecurDyn or student version of RecurDyn to try them. At the beginning of this starter kit, I introduced that RecurDyn provides various toolkits and MFBD based on RecurDyn Professional. I will introduce Toolkits and MFBD briefly here. As I introduced, RecurDyn has various toolkits. Toolkits for machinery, engine, track, media transport, drivetrain, and other applications. Here, I will show you the simple demo of MTT2D and TrackLM. MTT2D is a toolkit which helps to simulate the printers or copiers efficiently. You can create the rollers or sheets which represents the papers with just a few clicks. So you can build a printer model within several minutes, which took more than several hours before. And the contact among rollers and sheets are defined automatically. Since this toolkit uses 2D model, it is much faster than 3D model. Without MTT2D, it takes much longer time to create this kind of model, and simulation time is also longer. This toolkit is widely used in the industry, which handles thin media like copiers, printers, ATMs, films, and various devices. So in this model, this paper will be transported in the left side by this roller, and this is the guide. So this printer will be moved here and it will move upward along this guide. Now this is the definition of the motion of the roller using function expression. Now will be simulated. You can see the animation like this. The paper, the sheet is moved here and move upward along this guide. RecurDyn has a toolkit called MTT3D, which uses 3D model, and there is also a toolkit called R2R2D, which is for the roll-to-roll model in big-size plotter or battery device. TrackLM is a toolkit to build the caterpillar tracks easily, which is used in construction machinery. TrackLM is for low mobility systems, and RecurDyn has a toolkit called TrackHM for high mobility systems. You can create the sprocket and roller and track link easily, and the specialized solver can simulate the model fast and accurately. Without this toolkit, it took even several days to build the track assembly, but you can do it very easily and fast with this toolkit. There are many sprockets or flanges or guard track links. And this is the track link, and assembly is done, and this is how to create ground, and this is the simulation of this track model. This is a simulation, and with the option the display animation during simulation. This track assembly moves on the ground. This is the simulation result. With just few clicks, track assembly consists of many track links was created, and this kind of simulation includes many contacts. But thanks to the specialized solver for track assembly, it can be simulated very fast. MFBD is the most unique and differentiated feature of RecurDyn. MFBD is the abbreviation of Multi-Flexible Body Dynamics, and it is also called FMBD or MBD-FE coupled simulation. MFBD of RecurDyn is a technology to analyze the dynamic behavior of the system, which include both rigid bodies and flexible bodies. It combines with MBD to analyze the motion of rigid bodies and FEM to analyze the motion, stresses, and deformation of flexible bodies. RecurDyn solver combines with these two components into one single solver. This provides RecurDyn with a much faster and much more robust solver than could be achieved through co-simulation. RecurDyn provides one consistent environment from mesh, modeling, simulation, and post-process. Especially, RecurDyn MFBD contact supports both of rigid body contact and flexible body contact, and even contact between rigid and flexible bodies. And other nonlinear problems such as large deformation, plasticity, and hyperelasticity can be solved. This is the MFBD analysis process I showed in the early page. In addition, you can convert a rigid body to a flexible body using MFBD technology. This shows the MFBD analysis process. As you can see, you can convert a rigid body to a flexible body and run simulation. Most of the other MFBD software can solve the linear problems only using modal superposition method and supports very limited flexible problems. RecurDyn solves all the degrees of freedom of the nodes and fully supports the nonlinear problems. So, in this model, a diaphragm spring can be simulated with a nonlinear contact. Then, not only position, velocity, acceleration, and force torque, but also the stress, strain, deformation of the flexible body can be obtained. These are three typical types of contacts: rigid to rigid, rigid to flex, flex to flex. You can use the same way to define the contact for any type and use the same contact parameters. Also, RecurDyn supports the self-contact within one flexible body. This is one example of RecurDyn MFBD CV joint boot. As you can see, the joint boot had a problem in this area. The boot was modeled as a flexible body, and the other parts were modeled as rigid body. The phenomenon of the physical test was successfully duplicated in a RecurDyn model, and it was possible to improve the design with this RecurDyn model. In this model, the nonlinear characteristics such as large deformation and the self-contact were considered. This is a vibration analysis of a robot arm, and one part of the robot arm was modeled as a flexible body, which shows the vibration. The main differentiators of RecurDyn MFBD are user can convert the body types between rigid and flexible body easily, and the joint, force, and contact attached to the body are preserved. As explained in the previous page, contact can be used for all types of bodies. Convenient UI that supports from mesh to simulation and post-processing. Nonlinear materials are supported. Durability analysis using MFBD results can be used. Deformed mesh can be extracted from the simulation result. This video shows a simple MFBD modeling and simulation. First, a rigid body excavator is simulated. This is the dynamic behavior of this rigid model. Then, This boom is converted to a flexible body. The built-in measure is used in RecurDyn environment. And when this rigid body is converted into a flexible body, the joints attached to the rigid body are preserved. And where the joints were attached, RBE are generated automatically. So users just need to convert the body types. Now flexible body is included, so simulation time is longer than the rigid model, of course. This is the animation of the MFBD model. And of course, contour plot can be used for the flexible body. See? Now, we are pretty much done with basic information. I hope this starter kit helps you get familiar with RecurDyn. And let me introduce some self-study materials for your further study. First, please remember this website address. This technical support site provides various information, including technical tips, FAQs, tutorials, and e-learnings. You can search information that you need and ask questions on the forum. If you log in, AI will recommend the articles for you. For beginners, 5-step course is recommended, including this starter kit. So, after starter kit, do simple examples of e-learning start. Then, e-learning dynamics provides basic dynamics example models. RecurDyn tutorials will be helpful to understand the various features of RecurDyn, especially do the professional tutorial first. Finally, there are 3 basic MBD models are given with minimum information. Please try them yourself. For intermediate level, I want to recommend the introduction of each entities or lecture about context. Articles about solver and checklists will be helpful for you. And there are many FAQs and troubleshootings, technical tips, and lectures about expressions. Also, there are many lectures about MFBD, especially please do the tutorials about G modeling or Meshir. In the RecurDyn installation folder, you can find many tutorials and examples. They will be helpful for you too. There are several kinds of books about RecurDyn. Especially, you can download RecurDyn for beginners for free. You can download that from Google Drive download link, this link, and this is based on RecurDyn V8, but the difference is not so big, so you can use it for RecurDyn V9. Okay, I think I explained all the basic information to understand multi-body dynamics and RecurDyn. At all events, you'd better try by yourself. Please try the examples in the starter kit by yourself using RecurDyn you have or RecurDyn student version. If you have any question, please use the forum in the technical support site. May the force be with you. Thank you.